Hello and welcome to this Engerati webinar. My name is Rose Bundock, Head of Commercial Content here at Engerati, and I'll be your host for this live session. Before we begin this webinar on cybersecurity paradigms within the energy sector, I'd like to go through a couple of housekeeping items. Firstly, the presentation is available to download as a PDF file. You'll find this on your screen under Event Resources, and also as an MP3 audio file for easy access. The webinar is also available on demand on Engerati, so you can share the key learnings with your colleagues. At Engerati, we like to make the webinars as interactive as possible, so encourage you to pose questions or simply make comments as we go along, so please do engage with our speakers. In this webinar, we'll be discussing evolving security paradigms, responding to the digital and data-driven grid. We're joined in the Engerati webinar studio by two experts on this topic from German research organization, the esteemed Fraunhofer Institute. Dr. Jörg Lassig is Professor for Enterprise Application Development, as well as Head of Fraunhofer IOSB AST Cybersecurity Training Lab, the Görlitz branch. Patrick Eikoth also joins us, who is Head of the Media Distribution R&D Group at Fraunhofer IDMT. Dr. Lassig, I believe you are kicking us off. Welcome to you both. We look forward to hearing your presentations. Over to you.
So, yes, good afternoon, ladies and gentlemen. Thank you very much for the kind introduction. And we have actually a quite tight schedule on this topic this afternoon. So let me briefly introduce that. So we start with an introduction to our cybersecurity lab. It's actually a federal initiative in Germany in which we are integrated, and I want to just introduce you quickly to that. And looking at the transition in the energy sector, we want to see which recent developments we have specifically for cybersecurity in the critical infrastructure field, and we motivate our investigations a bit. And of course, I'm from the practical side, I'm a computer scientist, so we really want to look into and attack also to see what is really taking place out there. It's not just that we see basically an increase in security issues. It's really also successful attacks, as we see in media, and we want to look a bit deeper into this and also do some analysis why are critical infrastructures so endangered. We next want to have a brief look on the legal frameworks in the energy sector. Specifically in Germany, we won't go too deep into this because I think it's here, of course, for us more interesting to look also at the legal regulations in the European context. And as a next step, after looking at the challenges, we of course also want to bit a look on solutions. What can we do on the infrastructure side in the energy sector? What can we do in general to handle the increased amount of data, handle data management in the smart grid, and also some solutions concerning applying specific algorithms, for instance, privacy-preserving data mining, or also specifically the privacy by design principle. And yes, Patrick will introduce us here to an example which has been implemented, and this is actually quite interesting. And I guess then we sum up this a bit and have hopefully a really nice discussion. Okay, let me talk about our cybersecurity training lab. You see here different topic areas: embedded systems, in industrial manufacturing, industry 4.0, digital forensics, critical infrastructures, and also software quality. Actually, That's a federal initiative with collaborations on those topics. In each of those collaborations, you have Fraunhofer as the biggest organization for applied research and development in Europe, actually, and on the other hand, universities of applied sciences, so that we have those two competences together. And in our consortium SSC, also in the footer of our slides, we have Fraunhofer IOSB and IBMT, two institutions which are collaborating from the Fraunhofer side. And main activity is that we address the industry in modular part-time study programs. We develop different classes and approach the most important and interesting topics in the IT security area at the moment, and for critical infrastructures. And very important also, as we see also on the next slide here, is the practical side. So it's not only that we investigate this area, we really also have hands-on sessions so that experts from industry can, together with us, work in the laboratories and see how certain attacks work and how defense scenarios can work. Of course, a very important topic is IT security management. If you have some cross-cutting characteristics like IT security, this is basically the only way to approach this topic in a really feeling professional way. And of course, for that we have the regulations and we have the legal frameworks. But it's of course also important then, if you go deeper also in the IT security management, to look at different scenarios, to, for instance, look at the role of the human in IT security, which is, as we will see, really quite important, even if you have large-scale attacks and typically humans are involved, and that's the first step before you look at defense strategies. Also, we of course do also together with different partners look into penetration testing, network monitoring, and activities and services like that. So let's look at cyber attacks, and specifically here in this slide on the coast side. Yeah, you see SMEs, small or medium-sized enterprises on the one side, larger companies on the other side, and you see different types of attacks, and the coast on average, and also the average then down there over all those different types of attacks. And actually, what is not on this slide is the average earnings of SMEs, for instance, which is about 47,000 euro according to this study. This means that actually already one attack eats up really a lot of this, and this shows how important it is to be prepared and to prevent such attacks so that they are not successful. Maybe you have heard last year about Maersk, like this logistics company, and those ransomware attacks, and they actually report that they lost $200 million in this attack, which is of course quite a lot. So there's really a high motivation to prevent this, and specifically. To see how urgent this is, I want to show you also this statistics here. That's actually showing the development of the number of malware items which are developed somewhere, get available, are used for attacks. And that's really in millions. So if you look, we don't have yet the numbers for 2017. So if you look at this gap between 2015 and 16, for instance, from 480 to over 590 million. If you calculate this down to one day, then you see that every day about 390,000 new items are coming on the web, are becoming available or used, and this is of course very difficult to monitor this. And here we specifically look at critical infrastructures, and that this is really also a very important and key topic you see in this slide. So here the question was to 580 experts specifically for IT security. What are the key drivers of changes in IT security today? And there are those typical items which you would expect: the Internet of Things or secret services, big data in general. But critical infrastructures are here in the second position because there's just so much transition taking place. And we discussed this basically also in this presentation, and this has to be addressed. And the last statistics about this, which is actually from this monitor for IT security of critical infrastructures, which was a survey taking place on the topic. And here we just asked the participants from the critical infrastructure field, but also in general from companies. You see this here in blue and in green. What kind of cyber attacks have you been observed or have been observed in your company? And you see two things mainly, or three. So at first, many different types. Then second, almost nobody had no attacks. And third, I would say, you see that you have phishing, ransomware, spam, really as the ones with highest number. And in those, of course, humans are involved. And human involvement in IT security is always a really sensitive topic. And this is also why in our classes we focus specifically also on this. Of course, a lot also on the technical side, but the human side is very important. So this was some motivating statistics. Okay, so the threat is growing. This we see clearly, and also, of course, and this is what I want to do next. There are successful attacks, and that's not just the one which I'm showing here, which is about this Ukraine power grid. You have also, for instance, in the past an attack on a melting oven in a German company which was completely damaged, or the Ruag case where a very long-lasting cyber attack was taking place. I think they gained in the end over 20 gigabytes of data over several years, and this company is actually quite close also to the defense ministry, and that's quite sensitive data. But let's focus on this, knowing that there are also a lot of other examples, and here we can specifically see a few important characteristics of this type of serious cyber attacks. And it's actually the first blackout worldwide caused by a hacker attack. And you see already the time when it took place, 23rd of December in 2015. So that's just before Christmas. So that's of course chosen to use maybe this specific situation. Next we see in a moment when I explain the details that it is this type of APT attack, which is an advanced persistent threat, and very target-oriented and over a really long time, like over 6 months. So they have really time to do an IT project in the end to attack. And we see that we have 30 substations, in some 30 substations for 3 hours offline, shut down, and so 225,000 customers had no electrical power in that time, which we have some calculation. There are some statistics. How expensive is that? So average is like 10 euro per customer per hour. So you can calculate. It's of course also quite some damage. So let's look at the details how this took place. So this is actually the network. We have the substations, of course, control station, some office network also, which is typically separate, administration, and you have also inside the substation then the circuit breaker and the control room and some other devices. And what is important also, you have to see it on the right side, a remote access to control this this system. And the attack actually took place quite in a similar way, as you may know. So some email to the administration, and then you get this security warning if the system is actually set up right. Because macros in office systems are typically disabled if you want to increase the security, and then you get this notification to enable the content. And here's actually exactly the critical point. And if many of those emails come in to different employees, only one needs to click on it, and this actually happened here. And what happens next is that this black energy malware is loaded from the internet. It's actually in this moment very difficult to even notice what is going on. This employee probably thinks, oh, okay, that was maybe a mistake, but okay, it went well, nothing happened. And yes, indeed, nothing visible happens, but then the network is actually infected by this malware. And here you see that the control station administration is connected, but in this case not really important, because what happened, they found here in the administration the login data for this remote access. So, and after this first attack, they have been indeed able to log in just as a normal employee and to be in the system and to investigate and to see what can be done. And indeed, they found this serial to Ethernet converter, and decided to do a software project to develop basically a new firmware for this converter. And this allowed actually to go further in this attack. So first of all, after this converter is developed and the attack is launched, some other steps are taken. So in this case, kill this to deactivate the control room, control station, so they have no more access anymore, can't really control the system, switched off basically. And then of course they also activate the features of their new converter, and this gave them the opportunity to switch off those circuit breakers. And very interesting in this attack, and which makes visible how professionally it was done. Also, this call center for customer complaints was taken out of the web in this case. So yes, and then the result we have already seen. About 30, not about exactly 30 substations are down and no energy supply anymore. And if you look at this CIA triads, so which are basically the values which have to be secured in our IT system: confidentiality, integrity, and availability. Then we see that they all have been successfully attacked. So, for instance, we are able to access data which should not be able nobody should be able to access it from the outside. So this feature has been hacked. Then if we look at the availability of systems, then that's also not given anymore in our case. The control team was locked out from the control system, and the circuit breakers were open, so the control was taken over, call center breakdown, and of course the blackout. So there's no more availability of service and also of the IT systems, of course. And integrity also not given anymore because the control commands have been changed here directly, have been hacked. So this successful attack, and we see again how synchronized this was. So multiple locations in 30-minute intervals attacked. APT, so from spring 2015 to December, more than 6 months, they have been investigating the system and just finally launched the attack. And also interesting, no zero-day exploits or anything which you may buy from the darknet or something has been used. It's just a vector to attack which is well known, and then the direct access to the control system and the human are directly involved in this attack. So let's broaden this question a bit. Why are critical infrastructure so endangered? Of course, we have to go back here a bit in time. You have seen it also in the structure here in this attack. Typically, those ICS, industrial control systems, ICS infrastructure, has been developed not to be on the web, air-gapped. And then, of course, security is less important. You see it down here on the slide. For classical information and communication systems or technologies, security, confidentiality is on top of the priorities. It should be at least like this. It's maybe not in any system. But for industrial control systems, not so much. But we are in the IoT world, so we connect those systems to public networks, and this opens up new vulnerabilities. This open design of the protocols is a problem. The packages are just encapsulated in TCP packages and easily detectable. You can take out data and can attack systems that way. And also here we want to look on some details. How difficult is this? There are actually search engines on the web which you can use yourself. For instance, Shodan.io, and you have here in the last line some figures how many devices are discoverable. There are statistics how many devices actually in statistics from last year. You have leading the US with most systems, ICT systems on the web. Germany, number 2, I think still 14%. And then, of course, in basically all countries. And you can search in a certain way. For instance, you can search for different for a specific bus system. 502 is Modbus bus, for instance. So in here you see the search result. And if you look closely to the slide, you'll also detect a few well-known companies, and you can find out details. Of course, this slide is a few weeks old, but may look different now, but it still can be checked like this. And you can go in details because as you have seen, you see basically IP addresses, and then you see also maybe what device is it, and you are probably with many devices able to open something like this. Here we just have done it. So some device from a certain company, and you have this maintenance login with username and password, and if you further use the web for this specific device, for instance, you may find the handbook with some information like standard passwords, and if those systems have been developed or have been implemented at a time when they were not really connected to the web, then the engineers did maybe not change it, and you could actually trace this further, because you find also when you are logged in software to operate within those systems and to execute maybe some commands and do something else all on the web, and find the software to do this. And this shows actually how critical infrastructures are also from this side endangered, because the development of a lot of IT infrastructure, technical infrastructure, stems from a time when security was not so much the issue. And now we specifically also want to look at the smart grid and smart metering, which is a quite central topic at the moment. The devices, smart meter gateways, for instance, devices used here. And we also want to look now on this data side. So we looked a lot on the technical side so far, but if we implement this transition of the energy grid, energy market, then of course also by the data which is collected, new problems appear. And just look on the right side, where you see those curves, how the power is used in a certain household, for instance, or by a certain company. And you see inactivity, you see certain activities, and there has been analysis that you can really trace it back, which device is switched on at which time. There are even energy management systems where you can give those devices a name, and then you see the statistics, when is it switched on, when is it switched off. And this gives quite a few opportunities to have now those devices in the households. So of course from this data you may get information about the lifestyle, even about the financial situation. If you just look which kind of devices are here, or how many of them, and how are they used, and this can give quite some insight. And manipulation can also go in both directions, with billing manipulation, that you pay less, or maybe that your neighbor pays more, or some company which is in the same market as you. And data readings can be manipulated, and also, as we will see in a moment, large scale, if those meters are manipulated, this may have an impact also on what the energy provider is doing. And in Germany, I really want to go to this only briefly and quick. The legislation also implements quite a few changes, and we have the Energy Act and the IT Security Act, BSI Act. But we want to focus here on this middle layer, Energy Transition, Digitalisation Act, and Smart Metering Act. And I think this is, of course, an example where really good ideas have been implemented, at least in this regulation, but it is quite hard to meet them. We had some analysis on this, also implemented part of that, and there has been also now analysis by the BSI, and actually at the moment we have no smart metering gateways which are really meet the certification. So we must actually distinguish between smart meters and also smart meter gateways. So for the smart meters, of course, we have them on the market, and we have certain requirements, how data has to be processed, collection, processing, transmission, storage, deletion, and also which connections we need to the communication networks, how they are secured, and how can we connect to the smart meter gateway. So this is quite well described and also implemented, but for the smart meter gateways, of course, it is then going more into detail. And it's also a lot about not just, as you see here, this connection, encryption, authentication of users, which is quite logical. It is also about roles, so that not each entity, each person that accesses those devices and this data can see everything. So we have different roles like the meter operator, network operator, energy supplier, and it can be controlled who does what with those devices, who can establish certain profiles, and who in the end can see which data in which time intervals. And not all data should be transmitted, and of course also how the data is transmitted in an anonymous way, pseudonymized or aggregated, so that you don't see it in like 15-minute intervals, so that you maybe just see still one data point over the whole month. And just if you want to have certain services, for instance, you want a reminder if you forget to switch off some device, the heating or the oven or something, then you get a text on your phone, for instance. If you want services like this, of course, then more information has to be transmitted, but this has to be signed. Actually, there's regulation about this, and there are also strict deletion periods of data, and in general, unique profiles for authorized access, so that it's completely clear who can access which data, but of course, quite difficult to implement, but it's of course also giving opportunities for new services, because this approach of course deals with data in a different way. So if you talk about transition in the energy sector and data, and for instance this metering data, and of course also about IT security in the energy sector. Yeah, this is only part of the challenge, because there's also a lot of challenge, of course, dealing with other sources of data which pop up, which come up by more complexity in the energy grid, different players. There's an energy market. You have fluctuating supply depending on the weather. So for instance, as you see here, you need forecast values for energy consumption. You also need to measure in the grid to have information how does the grid look like at the moment, and to plan further, so some kind of state estimation. Then trading is of course taking place, but you have not only this market side, and you don't act only market sensitive, you also have to look at this network side. Those depend on each other, because you can of course only on the trading side, on the market side, act in a way that the network can also digest this, that the network can support those actions, and billing, of course. So part of this information has been there, of course, always. But in general, this calls also for new ways to handle this information on the infrastructure side, and principles as, for instance, security by design, privacy by design, as we want to look at. And let's just, for motivation here, also look on this infrastructure side on some new principles. We actually implement them in a project together with energy providers, and also network managing companies. And so here we use a new paradigm called microservices, for instance. So you may know that a lot of IT systems, IT infrastructure is operated with virtualization. You see here, for instance, on the left side, those guest operating systems which run certain applications of the infrastructure. And with the use of container technology, Docker for instance, you can do this a bit more easy, and you don't need so many resources. That's more efficient, and this opens up to, for instance, run microservices. And using those containers has also advantages in general on the infrastructure side, because you can run those apps really isolated. So let's have a look now at all this data again, but with a bit more infrastructure here integrated. So you see in the center a database. This is the classical approach, but yeah, the classical approach to have everything in one database and some services feeding the database is not the most flexible way, and also not the most robust way, and it's also not scaling really to handle data. And this is why this approach with microservices opens up new possibilities. And now you see on this ring here different services, and you see those different services handle data. And if you use the right software frameworks, those microservices have some orchestration. You can scale. For instance, if certain type of data is used more and the service is used more, then you can scale, and you have 2 or 3 of them. And it's also possible if you are hacked or there's some attack or some problem, then only one service is down, and you can have even kind of automatic monitoring, what's called organic computing before, maybe you have heard of this, so that the system regulates itself. So looking at the time, I think I should be also a bit quick here. You can see, of course, the details, what type of data has to go in here. You see on the left side state estimations. We have the network state. We have the metering data, so different types of data. If you want later on in discussion, of course, I can also explain this more in detail. Here, maybe the IT side is more interesting. And this is just, of course, very little insight on those technologies. There are other technologies. You see quite classical ones. If we go again to the data security more, then we, of course, use also in approaches like this, classical schemes like cryptography, encryption, signatures. We must think about ways to have contracts between systems, because IT systems get more and more complex, and humans can't really be involved in any process. This is why principles like blockchain are also important for accountability, for trackability, and of course, blockchain is just a buzzword. There are, in the meantime, other principles which fit this better, and in future there's a lot coming. And also on the design pattern side for data analysis, there's a lot to talk about big data, artificial intelligence, deep learning. There's, for instance, privacy preserving data analysis, so that you don't even have to exchange data to analyze it. You look, for instance, at the supply chain, and you have data on the different stations in the supply chain. At the end, you have, for instance, some smartphone which is popping out, and you have replies from the customers which phones work, which don't. Then, of course, the producers maybe don't want to reveal all the data, but it's possible to do some analysis and learn about where are the problems in the supply chain without exchanging this data, which is kind of interesting, and it's a principle which can be applied also for energy. Other principles and to one implementation of this privacy by design principle, using anonymization, pseudonymization. We have now Patrick, who goes a bit deeper into this and explains us that also on example, which is also not exactly in the energy field, but really motivates this well. So Patrick, I think you can go ahead.
Thanks, Jörg. So I would like to quickly go. I have to hurry up a little bit with the timing. I think I will go quickly into some key terms which are important for the context of pseudonymization and anonymization for this example. So, of course, there's person identifying and person identifiable information. There's pseudonymized information, and there's anonymized information within systems. As illustrated with the examples below, you would say, for instance, my real name, Patrick Eichroth, downloaded a specific asset today versus a user with a specific number downloaded a specific asset today versus someone downloaded a specific asset today. So you have for the first, you have that's information that's referring to real identities. The second is not really referring to real identities, but using respective IDs. And the third is not using IDs at all, basically throwing everything in one pot, so to say. And from that is already clear, you cannot really use anonymization for under all circumstances, because without the differentiation among IDs, you cannot do certain types of analysis, for instance, for personalization or recommendation within a system. That is one limitation. A second limitation is illustrated at the bottom, which is unintended de-anonymization or re-identification. If you have attributes in the system that, if combined or especially combined with external databases, very often you have a substantial risk of an intentional re-identification of assets. So that is a second challenge to be considered in that context. And then the third challenge, that's the one I would like to focus on, is in practice and in systems, very often you have a registration of real identities. Like in that case, I put my name here. It's in the table in the middle. And then you use random mapping, encryption, or cryptographic hashing to derive unique pseudonyms or IDs from that you use within the system. And you try to keep those separate, which is a good idea. What do you try to do with that? You want to have a one-to-one mapping from real identities to pseudonyms within your system. But at the same time, you also want to avoid that others or even yourself are able to go back from a pseudonym that you created to the real identity, which is often to be protected. The problem is that the standard approaches for this have their limitations. So if you lose, if you have cases of data loss or hacking, then it's always possible to recreate that mapping and to go back. And that turned out to be quite a problem in many of our projects. So we had many projects and domains where which are about data exchange and analysis to improve efficiency and to establish new business models in systems, in domains, and they use IDs about users, sensors, and devices, but at the same time, the participants absolutely don't accept if there is a traceability of these IDs back to their real identity or of their customers. So this leads to losing credibility and know-how, loss of data sovereignty, and also creates data protection law issues, of course. So how can this be solved? That was the question that we had. And it can be illustrated with two examples. With a standard registration at the moment, referring to the first slide that I just showed, typically you register real entities, real users, devices, or sensors, and then directly or indirectly, it is always still possible, even with some effort, more or less effort, it is possible to go back to the real identity within the data analysis phase, so to speak. Which means, yes, you can do the analysis you want to do, but the problem is the real identities and data sources are still traceable, even with some effort. So that is not what we want. In the case 2 that we also had on the first slide already, if you anonymize things, then you don't have to worry about traceability of the data sources anymore. That's good, but what's not good is that you cannot do many, if not most types of data analysis. You don't have any IDs that you can use to differentiate. So that is also not desirable. What we developed a couple of years ago was an approach that takes real identities and creates pseudonyms from that, but in a way that basically you cannot go back. So it basically strongly decouples the real identities and the virtual identities, and the virtual identities can then be safely used within a system without the risk of somebody going back to the source. So how do we do this? The approach is based on the idea that we split the registration process in two. So on the left side of this triangle, you have a registration step where the real identity is validated by a service, by our service in that case, or software that we provide, using information that points to the real identity. And then in a second step, which is on the right side, certain information from the first step is used to then create a virtual identity that has a one-to-one relationship to the real identity, but cannot be connected with that. The way we do this, roughly speaking, is by using a combination, and that's what the patent, a respective patent, is referring to. We use a combination of so-called oblivious transfer and token management, a specific type of token management. The way it works is then when a registration on the left side is done with your real identity, the server provides you a token package, so to speak, and distributes it using a protocol where the server itself does not know which one you selected as a client, and you can only select one as a client. Then you take that token package and register yourself with a second service. That's the service we are really what is used later on. And then this token package is used to validate that there was a legitimate first registration step, and it is used to create a virtual identity for you or for an asset or for a device, but there's no connection between the two. So if we make sure, and that's the condition of course, if we make sure that we do not communicate other person or identifying information over the communication or with the data that we communicate, if we make that sure, then even in cases of data loss, it is not possible to connect the information on the server side, even if you would lose information for both of them. There is an important complement to this approach, which is what we call re-identification analysis. As mentioned at the beginning, there are many risks on unintentional re-identification within systems, and we use this software to have a statistical analysis on how probable a re-identification is, and to have that, to basically be able to keep that under control, and to also apply anonymization techniques to get hold of that. There is one example for where we have applied this approach, and we will now watch a video on this.
The growing importance of online commerce has led to an exponential increase in the volume of parcel shipments in recent years. Especially in urban areas, different parcel services deliver the ever-increasing number of shipments on the same routes. Most of these journeys are to be replaced by joint shipments by the various parcel services to final distribution centers. From these hubs, the shipments find their way to the receivers by bicycles or e-scooters. The problem? Competing parcel services have to deliver all shipments to so-called consolidation centers. However, they do not want to share their data, the recipients and sender addresses, in a joint system. Zoido offers each parcel service the ability to create non-traceable virtual IDs for its shipments. Through the patented two-stage registration process, each shipment receives a decoupled identifier and is given the number of the destination hub. Cooperative data sharing offers benefits to parcel services, cities, and customers. Shipping becomes more efficient, causing less traffic, and the communication between parcel services and recipients is enhanced. For example, customers can now have multiple shipments from different parcel services delivered simultaneously. The number of undeliverable shipments will be reduced. Zoido, enabling data-driven business models.
So, as illustrated in this example, the approach can be used to promote trust by protecting real IDs and data sources within a system. It can also help simplifying dealing with data protection challenges, and it in general avoids collection of unnecessary problematic data, which is also good from a security perspective. It's currently applied in various domains: smart cities, smart construction, Industry 4.7, and other domains. The question is, can it also be useful for smart grids? Handing over back to
Patrick, thank you very much. Yes, that's actually an important question. And of course, in energy market, there are similar patterns where you may be able here to solve some problems using patterns as this. But I think if I look at the time now, we are really also running out of time. So please, let me talk some concluding words only. So we have seen actually quite some challenges, but we have also seen what are possible solutions to shape basically this transition in the energy sector. And I want to point at this point at our bootcamp in Lisbon. I think it's taking place in September, and this will be the place where we can address those questions deeper and where we have the time to do this. And of course, we are going to look at those technologies and other technological approaches to solve here certain problems. But I think it is similarly important not just to go through this transition and to manage the challenges from the IT security side and to manage the data. It's also important to look at business models, because we are not in the empty room, so we have to do our business. And there are, of course, there are other ideas coming in. I talked already a bit about smart contracts, app stores, and so forth. And we can do this only in the European legislation framework. So that's it, and this is taking place in Lisbon. So for now, thank you very much for listening. And here you see a few links you can use to get more information. And please don't hesitate to write us also an email if there's something. Or I hope, of course, for a good discussion now. One last slide here. Have a look here at bootcamps.ise.innoenergy.com in September, also about our bootcamp there. You can learn here how it's possible to participate. And you see on the way there, we are still, of course, approaching those topics. We have other webinars, e-learning sessions going on. We develop modules to go deeper into those contents. And I hope you will also join us there. Thank you very much for now, and let's go into the discussion.
Thank you, Jörg. Thank you, Patrick. Obviously, it is a big subject, so needed a lot of time to go through that. We've got some questions here. The first one, there's a truth that, or a belief that cryptographic code will be broken by a hacker one day. What implication would that have for smart grid security? Patrick, potentially to you to begin with.
Patrick, you want to answer, or shall I just go ahead?
Okay, I think it's better for you, yeah.
Okay. So cryptographic code to be broken is of course quite general. So we have seen how it's possible to really have big security issues, and in this sense, of course, the attacks take already place, and sometimes it's of course possible to break also certain cryptographic codes. For instance, if the passwords are too short, you can have some brute force attack, or certain codes are just less secure over time because the computational power increases, or there may be some backdoors. For instance, TrueCrypt, you know, the software which was used for encrypting hard disks until a few years ago, and later on it disappeared because there was probably some problem with this code, and this of course can also happen by other technical developments. For instance, if you look at quantum computing, you need at least for symmetric encryption longer keys, and asymmetric encryption doesn't work anymore that way. So we have to deal with this. Of course, there are other developments for cryptographic systems, post-quantum systems, for instance. But we must say at this point, I think that this is by far actually the least risk. So the higher risks come really from human involvement, mistakes that are done by humans, and basically issues which we have in our security system. This is why systematic implementation of IT security is so important, and is of course done specifically in Germany, but worldwide. This is a high priority at the moment. ISO 27001, for instance, and you need to implement the IT security management system to really look at the different parts of this cross-cutting characteristics IT security.
Thank you, Jörg. Another question here. Which is more critical in your point of view, from your point of view, microgrid or smart meter access ID?
I think in general, you can't really trade this against each other. You must here really then look at the details. And I talked here specifically about smart meters, which is quite good example for having those principles and like IT security by design principles, which are implemented here. And implementing it actually is just underway. It's quite difficult, and what the real issues here will be, we will see more actually when it is in action, which is at the moment still really on a small scale. There are certain pilot projects about this, and we will see the issues here. And with microgrids, of course, there are those implementations, and you have to secure those also so that they can't be accessed, that there can't be any manipulation, and you have to use again the principles to implement this in a systematic way. Yeah.
Great. A question about blockchain. Is it only through a token mechanism or within the Ethereum blockchain platform that you'd use that technology?
Yeah. So blockchain is of course really hyped a lot, and I did hear certain talks to use blockchain technology, and if you look really at the use cases, I think the use cases how to use it are at the moment still unclear in the application domains. Of course, we have a few application domains, and we have also issues of the blockchain technology. So I look at blockchain technology more as a technology which it's a new database paradigm actually, and you have basically your transitions in the database, and those transitions are distributed on each machine that is taking part, and then you have your hash over those transactions, so you can't really change the history in your database. This would be revealed, and this actually gives you, of course, some opportunity to implement schemes as smart contracts, for instance. And now IOTA, of course, is a big topic, and IOTA is pushed that this will be the implementation of post-blockchain technology using same ideas in different domains, and specifically in industry. There is this consortium of quite a few industrial partners here, and what will be used in the end, if it is Ethereum blockchain or if it is IOTA or something else. I think this is still unclear, because it's I think more important at this point to really work out the use cases, because what we want to do in the end is of course business in this sense, and for that we need also the business cases, and then we need the tools to implement the business cases, and this blockchain or some similar technology is the right way to implement it. Then we can of course apply it, and I think there will be quite a few use cases that meet those technologies, and which just appear by using those technologies.
Thank you again. Patrick, if we could just bring you in at the end, we're running out of time, but for the audience, utility professionals, what would you say is the key learning for them to take away from this webinar? What should be front of mind?
Well, I think one thing worth mentioning in general is what also Jörg has focused on or mentioned several times, which is a by design approach for many of the things that we both presented, both for security but also for privacy. So the sooner this is integrated in projects and for products, starting from the requirements analysis already really through all the development cycles up to the end, the sooner this is done, the better it is, because you reduce the cost and you avoid huge problems that you have if you ignore that. And that goes both for security and for privacy concerns, I think.
Fantastic. Thank you. Good advice. Thank you, Patrick. Thank you, Jörg. Thank you to the audience for tuning in for your questions. As the presenters mentioned, Fraunhofer will be taking part as a content partner in the InnoEnergy Internet of Energy Bootcamp, which culminates in Lisbon. You can find more details about that under partner events on engerati.com. And you can find plenty more of our webinars live and on demand. Thank you for tuning in today. Goodbye.
Thank you very much.
Thank you.